Imagine living in a universe where nearly everything around you is invisible, yet has an iron grip on the cosmos, pulling strings like a puppet master, directing galaxies like they were mere actors in a cosmic play. This is the shadowy world of dark matter, a substance we know almost nothing about yet believe makes up most of what's out there. Buckle up, because we're about to dive into the strangest, most frustrating, and yet most fascinating game of hide and seek in the entire universe, one that even Einstein himself couldn't solve. The mystery that haunts physicists' dreams. Let's start with a question. What's the one thing that keeps physicists up at night apart from the fear of spilling coffee on a multi-billion-dollar detector? You guessed it, dark matter. We think it makes up around 85% of the matter in the universe, yet we haven't actually seen it. Recent experiments like Lux Zeppelin have been digging deeper into the dark for answers, setting new records for sensitivity. It's almost like searching for your missing socks. But these socks might never have existed in the first place, and you still swear they did. Supported by a multi-nation collaboration, Lux Zeppelin has used about 280 days of data to further refine our understanding, making it more like a year-long scavenger hunt without any treasure, except a few clues that may eventually lead us to the prize. Dark matter's surprise dance partner, regular matter. In the latest twist, new studies suggest that dark matter might interact with regular matter in ways that go beyond gravity. This is groundbreaking, as dark matter was previously thought to be as aloof as a cat that just ignored you while staring directly into your soul. The potential for dark matter to engage with forces beyond gravity could completely change our understanding of the cosmos. Imagine dark matter not just bending space-time, but also chatting with other forces like electromagnetism behind our backs, kind of like that mysterious person at the party who secretly knows everyone there. The bread experiment. Tinkering on the kitchen table. Another quirky approach to understanding dark matter comes from the bread experiment, which aims to detect Axions, a theoretical type of dark matter particle. The bread team at Fermilab brought particle physics to the kitchen table, figuratively speaking. Imagine your grandmother's cookie baking setup, but instead of cookies, it's about dark matter detection. These small-scale experiments show that not every breakthrough needs a giant particle accelerator. Sometimes all you need is some ingenuity, some tabletop tech, and maybe a little sprinkle of hope. What's even more fascinating is that these experiments have been able to demonstrate impressive results without the vast funding and infrastructure typically associated with large-scale research. The next phase of bread will involve collaboration with several national labs, emphasizing the significance of merging creative, small-scale projects with major institutional muscle. Mapping dark matter's invisible influence. If dark matter had a role in the movie of the universe, it would be like the off-screen director, moving stars and galaxies without showing its face. Scientists have used the Rosetta telescope to map the universe, which suggests dark matter has played a key role in shaping the cosmic landscape. This influence is invisible, but its effects are undeniable, like that one friend who quietly organizes the road trip and doesn't get enough credit. This new map offers one of the clearest views yet of how dark matter orchestrated the evolution of the universe. By examining how galaxies cluster and interact, researchers can trace the patterns dark matter left behind, almost like reverse engineering a mystery plot. This cosmic mapping isn't just visually stunning. It's a critical step in understanding how dark matter and regular matter dance together to create everything we see around us today. No dark matter, said one brave study. In a classic case of maybe everything we thought was wrong. A study from the University of Ottawa claimed our universe might not even have dark matter at all. They threw the cosmological cat amongst the pigeons by challenging the mainstream model, suggesting we may not need dark matter to explain certain cosmic behaviors. This kind of thinking is like standing in a crowded room where everyone's confidently wearing sunglasses at night, and you're the one asking, "Guys, are we sure about this?" If this controversial model is correct, it would mean many of our theories need to be reworked from the ground up. However, it's essential to remember that in science, bold claims require bold evidence. So this study has spurred renewed debate and further scrutiny of dark matter's mysterious presence. Looking for wobbles on Mars, microscopic clues. MIT researchers recently suggested that primordial black holes could account for a portion of dark matter. They theorized that when such a black hole passes near Mars, it could create a small wobble. This means that scientists are basically out there waiting to catch Mars acting tipsy, hoping they'll tell us something about dark matter. It sounds like a bizarre cosmic dance, watching planetary movement for clues about ancient, tiny black holes that might help us make sense of the cosmos. These primordial black holes are hypothesized to have formed soon after the Big Bang, making them some of the oldest objects in the universe. Detecting their effects, even subtly, could unlock secrets about the very origins of cosmic structure and dark matter's place within it. The cosmic web, dark matter's threads. Have you ever seen a spider's web glistening in the early morning? Now imagine that on a universal scale. Researchers have found dark matter dangling from what they call the cosmic web. It's like dark matter is weaving an enormous net that holds galaxies in place. Even though we can't see it, this cosmic web is crucial to how the universe is held together. Without dark matter, galaxies might just drift apart, like friends from high school who lost touch over the years. What's particularly fascinating is that recent findings suggest this cosmic web isn't static. Dark matter continually shapes and redefines how galaxies and clusters evolve. It's the unsung hero that keeps the whole cosmic party from falling apart, tirelessly at work behind the scenes. Dark matter detection, faster than Moore's law. Imagine a rate of technological progress faster than Moore's law, the prediction that computing power doubles every 2 years. Well, that's what physicist Kravitz claims about our ability to detect dark matter. We're seeing exponential improvements in the sensitivity of our detectors, meaning that what once seemed impossible is now increasingly within our grasp. It's like we're moving from using a magnifying glass to look at the stars to using a telescope powerful enough to see grains of sand on Mars. These advancements are making it possible to test hypotheses that a decade ago were merely thought experiments. The rapid progress brings new hope that we may one day have concrete evidence of dark matter, making it less of a shadowy concept and more a tangible entity within our scientific understanding. Gravitational waves and the LIGO connection. LIGO, famous for detecting gravitational waves, is now also being used in the search for dark matter. Researchers suggest using gravitational wave detectors to spot tiny shifts that might signal the presence of scalar field dark matter. It's a bit like using a finely tuned drum to detect footsteps in the next room, except the room is the entire universe, and the footsteps belong to something that may or may not exist. The precision needed for this kind of detection is extraordinary, but it's also the kind of bold approach that often leads to groundbreaking discoveries. By analyzing slight perturbations in gravitational wave signals, LIGO might provide insights into forms of dark matter we've never considered before, pushing the boundaries of both particle physics and astrophysics. Is dark matter magic or a practical joke? If dark matter was a person, it would probably be the prankster who keeps everyone guessing. It's there, but it's not. You can't see it, but it affects everything around it. From challenging our notions of what makes up the cosmos to breaking the norms of how matter interacts, dark matter keeps physicists scratching their heads. Some still joke that if you can't explain something, call it dark matter. After all, it's the ultimate cosmic scapegoat. Theories range from interactions beyond gravity to particles like Axions or primordial black holes, making dark matter the wild card of physics. It's a challenging enigma, and just when we think we're getting closer to answers, dark matter seems to pull a disappearing act again. But like all great mysteries, the quest to understand it keeps us coming back for more. And that's our deep dive into the mysterious world of dark matter, an invisible force shaping the universe and keeping physicists up at night. If you enjoyed this journey into the cosmos, make sure to hit that like button and subscribe for more engaging content like this. Don't forget to turn on notifications so you won't miss our next adventure into the unknown. Thanks for watching and stay curious.